Hello, welcome to ISC West 2025. My name is Mohamed Haidara with MemryX. I know some of you may have not been able to make it to the show, so let me show you a little tour of what we've got set up here today. All right, for our first stop, we're gonna show you a head-to-head comparison between MemryX and NVIDIA Jest and AGX Orin. So on the left-hand side, you have the MemryX M.2 module in our x86 evaluation system, and on the right side, you have the NVIDIA AGX Orin, 64 gigabytes again. What we're gonna show you is a simulated bike race where both systems are running the same exact model, YOLO V8 Nano, and they're running it at the same resolution, 320 by 320. I'm going to start the bike race, giving the NVIDIA a slight advantage, and then I'm gonna launch a MemryX system after that. What you're going to notice is the overall performance. You're gonna see that we're achieving over 2 times the frame rates that they can do in terms of inference. We're talking about a system that our system costs 25% the cost of the NVIDIA AGX Orin 64 gigabytes, where we're achieving over 2 times the performance that they can do. Looking at the bike race, you can see on the MemryX side, we're already done, whereas the NVIDIA bike race is still ongoing. Again, emphasizing the fact that we are twice the performance for a fraction of the cost. For the second stop, we're showing you our YOLO World demonstration. This is basically a zero-shot object detection model that came out last year, and it's able to learn new objects on the fly without any data sets, without any additional retraining required. I'll show you a few examples of what that means. We're looking at a stuffed toy or a watch, for example. I put it on the screen. The camera doesn't know what that is because the model has never been fed any input to identify this. Now, what we're gonna do is we have a list of classes. We're gonna add stuffed toy, watch, and even maybe a phone to that list. Here we go. So let me do 1. Let me do 2. And then let me do the third one as well. Now I'm gonna hit apply. I'm gonna hit apply. Now what's happening is the language inference portion is running on the CPU. It is modifying the model parameters to learn the text input we just provided. This gets fed into the MemryX neural compiler, which ultimately within seconds is going to compile it, and voila, it's going to be able to identify this new object that the system had never been trained to know before. You're saving valuable time in terms of taking thousands of pilot images, going through the process to build up a model around that and make it effective. We're almost there. By the way, it takes maybe 60 to 120 seconds versus talking about weeks, if not months. And we're almost there. So again, you saw initially the stuffed toy could not be identified, the watch could not be identified. Now let's see. You can see right away, it's able to draw a bounding box side and it knows based on text input alone what this is. The same thing happens with the watch. If I were to add a phone to the list, you're gonna see the same thing. This is showcasing MemryX efficient architecture, and by the way, we are the only AI accelerator company that's able to support this natively today. For our third stop, we're showcasing MemryX multi-model face detection. Essentially what you're looking at here is you've got 2 different frameworks, 2 separate models all running parallel on our chip simultaneously. And by the way, without no software control. Mr. Frosty, my model, is gonna step into the screen and I'm gonna showcase. So right now you can see that he doesn't know who he is. We're gonna take 3 shots. I'll start by adding his name. Pressing go. Can you please turn to the right? And then to the left. Got it. So 3 images is all we needed to get this up and running. Now I'm gonna ask Mr. Frosty to step out of the scene and step back in. What you're going to notice is as soon as he steps into the scene, it's going to be able to pick him up immediately without any latency whatsoever. And if you were to step further back away from the screen, it's still able to recognize him. Let's see, how about we were to block part of your face if you were to cover your mouth? Is it going to detect you still? It's still able to detect who he is. Yeah. So again, this was compiled within minutes with a single command, keeping it very simple and highlighting our architecture's agility overall. For the final stop of our tour, we're going to show you our 100 video stream demonstration. What this is going to highlight is our ability to scale and add more AI compute where required to handle heavier workloads. So first, you have 4 of our M.2 modules connected into this carrier card here, which is connected into this AMD Ryzen x86 box. We are running YOLO V8 Nano 320 by 320 resolution. We are pumping 100 videos, pre-decoded video streams onto the module, and it's able to achieve over 30 FPS inference per video streams. We're actually achieving 43 overall. This highlights our ability to scale, add more AI compute where required, and take care of your overall heavy workloads. Thank you very much for stopping by to visit us this year at ISC West. We are looking forward to connecting with you at additional shows to come later this year. Please follow us on LinkedIn to stay up to date on the latest we've got going on. Thank you.